like that. Hi everyone! I'm trying to get both my cameras lined up. I shouldn't have touched them. I had it perfect last night. I was pretty happy with how it was last night. Today, not so much. Let's see if I can do it all. There we go. There we go, there we go, there we go. I'm wondering if I should turn it that way. Yeah, I think that's better. Hi everybody! Don't be stressed, don't be stressed, don't be stressed. Where are we at? Okay. Yeah, so we'll do foundation, although I've got the higher up. We'll do foundation from 7 till 8 and higher from 8 till 9. And it's going to be June 2019. That was the requested paper, so that's the one we're doing. I'm good. How are you all? I'm very, very well. It's been a long day. I'm sure you all are aware it's a very long day. It's been a very long day. So we're doing foundation from 7 till 8, higher from 8 till 9. Foundation from 7 till 8, higher from 8 till 9. Foundation from 7 till 8 p.m. and higher from 8 till 9 p.m. as always. And we'll do June 2019. It says May because it was done in May, but that's the year. June 2019. That's what we're going to do. So foundation from 7 till 8 and higher from 8 till 9. I'm not loving this camera on YouTube. Hang on. I'm wondering if I can move it. Oh, no, I'm going to mess everything up. Hang on a minute. There's no point doing this for 2 hours if no one can see everything. Hang on a minute. Right, I think that's better. She says. That's better. Now everyone can see everything. There we go. That is better for everyone, I think. Good. So I'm live on TikTok and also live on YouTube. So watch wherever you want to watch. I want you to write on the paper, Taylor said so. I am writing on the paper. What do you mean? Oh, right here. So the grade boundaries are always set after the exams happen. So we don't know what the grade boundaries will be until afterwards. There's some good topics to do. So if you look on the First Class Maths papers, so if you go to First Class Maths' website, oh, I say that, I haven't got it open. If you go to First Class Maths website and you go to exam papers, so a lot of you will have been given these by your teachers this week. So you've got 1A, all these papers done by First Class Maths, 1B, all these papers done by me. And so if you click any of them, either or, so if you go Edexcel Foundation, for example, the second page is just a really good list of things that you're going to want to revise before tomorrow. They were all the things on these practice papers. So if you've done the practice papers, these are going to be the things that are good to watch. So I will record this and I will upload it on YouTube. So if you're wanting to watch this afterwards, it will be on YouTube late into the night, I would imagine. But you guys should all get an early night, not be up late on TikTok. So that's the list for foundation. And then again, if you wanted the list for higher, it's there. You can go into the higher paper and have a look at the second page. And again, so these are things that First Class Maths did a whole analysis of all the past papers that have gone by. And these were just topics that came up lots. We've obviously got no idea of knowing what actually is going to come up. There's no way of really knowing. But these are things that tend to come up lots. So it's just a really good guess, likely to come up on the paper tomorrow. Tomorrow! I can't believe it's tomorrow. I'm so excited. So if you just go on First Class Maths' website, they are there. First Class Maths, 1ST, Class Maths. Foundation 7 till 8, higher 8 till 9, always the same. I've been doing this since December, every Wednesday and every Sunday, which blows my mind. If you've been here since December, well done. We finally made it to the exams. I can't believe they're tomorrow. And I think the most important things you can remember for tomorrow's exam is that never, ever leave anything blank, okay? If you leave it blank, you're basically saying, yeah, no, don't worry about it. I don't want any marks for this question. At worst case scenario, just guess 2. 2 is always a good guess. 15, 12, I don't know. Just have a sensible guess. Write something that makes sense. Never, ever, ever leave anything blank. So I examine GCSE papers every year. And obviously, as an examiner, I get to a blank question. I'm like, great, easy, no marks. Very quick for me to mark, but not ideal. Not ideal at all. So we start at 7 o'clock, 7 till 8 for foundation and 8 till 9 for higher. We are starting at the beginning of the foundation paper. And then by 8 o'clock, we normally hit the crossover section. And so we'll start the higher paper at 8, but that will be the end of the foundation paper as well. And then we'll go through. Do I know what tomorrow's paper will be? No. Only the people that wrote those papers know what they will be. Even as your teachers, we are not allowed to see the exams until you come out. So I will not see the paper tomorrow until like 10:15 or whatever it is, when you will come out of it and tell me how it went. So I can't wait. So for grade boundaries, my favorite place to look for grade boundaries is a website called MathsBot. So if you go to MathsBot grade boundaries like that, and you can put in what board you are. So let's say you're Edexcel, because most of you are. You can put all of the years, you can put in all of the series, and you can put in foundation, for example, and it will tell you what it tends to be. So if you are looking for a grade 4, out of all 3 papers, it tends to be around 133. Sometimes it's been higher, sometimes it's been lower, but you can see what it tends to be. So if you divide that by 3, yeah, we're not doing November, we're doing June 2019 or May 2019. Make sure you print the right one. Higher would be like that. So foundation we're doing tonight from 7 till 8. Higher we'll do from 8 till 9, starting at the very beginning of the foundation paper and working our way through. So hope to revise as many topics as we can. So tonight we are doing this one, May 2019. We voted on it last week, and that was the request for tonight's paper. May 2019 was the one that we're going to do tonight, or just it might be listed as June 2019 because technically that's when the series is. Don't be scared, okay? The more scared you get, the more worried you're going to get, the more anxious you're going to get, and you're going to start to overthink things and panic and not read the question, okay? It is what it is. You guys have done hundreds of thousands of hours of maths lessons, and you will be wonderful. Maybe not thousands of hours. I don't know. Someone do the maths on that. How many hours will you have done from year R up to year 11 or whatever your equivalent is? Question, Megan, you are a hero. Question 21 is the last foundation paper question. And Megan, can you look for me on the very, very end how many are only on foundation at the end of this paper? Because normally it's the last one question, but it might be 1 or 2. Thank you. Yeah, so look up MathsBot grade boundaries if you want to look up the grade boundaries. MathsBot grade boundaries is a great place to look. So I'm doing foundation from 7 till 8, higher from 8 till 9. There's lots more on YouTube. So remember, if you didn't catch last night's stream is on YouTube. So that is there from last night. Oh, that's now. Last night's stream must be somewhere as well. I don't know where it is. We've also got top 5 topics for tomorrow for higher. Yeah, and the predicted papers that First Class Maths wrote, they're there as well. Foundation there, fractions, adding and subtracting, things that come up lots. So lots more on YouTube. Hannah Kettle Maths on YouTube there. And for the predicted papers for First Class Maths, he's obviously First Class Maths on YouTube as well. 2 minutes. 2 minutes and then we're going to start. So if you want to print it, get it printed. How have all your exams gone so far? I'm doing the same paper for higher. So May or June 2019. People seem to be happy with the exam so far. Except from the girl that just popped up on my For You page saying that she wrote about the Grinch. I don't think she wasn't so happy. Christmas Carol. I think she got some confused. They're going 6 so far. I'm hoping it's the same for maths. I just want everyone to enjoy the paper. I know that sounds silly, but when the paper's really hard, yeah, the grade boundaries go down, but also it's a less enjoyable paper, isn't it? It's nice when you can get stuck into lots of questions and really get that satisfaction of getting lots of marks. Believe it and you can achieve it. Yes, from Jazz. Absolutely. Love that. I would never enjoy the paper. Yeah, don't worry. If you do AQA, don't worry. A lot of the content's going to be exactly the same. It's still going to be helpful. So don't worry about that. No worries. Okay, right. Shall we begin? 7 o'clock. Let's get started. So remember, always being kind in the comments. Please big each other up, help each other out. The comments go very quickly. So if you saw someone had a question, please help them out and answer it. Be kind, you've got this, let's do this. Okay, so non-calculator, obviously ready for tomorrow. Question number 1 was to write 180 minutes in hours. So first thing I'm going to do is say, well, 60 minutes is 1 hour, and therefore 180 minutes, that's 3 times bigger, so that's going to be 3 hours. There we go. First one, very nice. Well done in the comments, everyone letting me know it's 3. Very good. So write 0.73 as a percentage. So percentage means out of 100. And we know that 0.73 is the same as 73 divided by 100 because it's been moved over 2 places. So if it's 73 out of 100, then that is just 73%. Don't forget 0.4 would be 40% and 0.04, that would be 4%. So don't get muddled with that. You're timesing by 100 to go from a decimal to a percentage and dividing by 100. Foundation 7 till 8, higher 8 till 9, guys. Question number 3, work out 10 times 3 add 8. Sorry, I'm doing the answer. 10 times 3 add 5. So 3 add 5 we're going to do first. Thinking about bid maths, we're going to do these brackets first. So 3 add 5 is 8. So we're just doing 10 times 8, and that is 80. Nice and straightforward. Okay, this is a really common question. Write down a prime number that is between 20 and 30. So it's a really good idea to know the first few prime numbers up to 29. I'd say up to 30. Well, 30 isn't a prime number, but up to 30 is a good idea to know them all. Yes, loads of you in the comments saying 23, 23, 29, 29. Yes, perfect, amazing. So we're going to do 23 or 29 for that. Your prime numbers are 2, 3, 5, 7, not 9, because that's in the 3 times table, 11, 13, 17, 19, 23 and 29. It is a good idea to know all of those because they tend to ask about them quite a lot. In this case, we just wanted one that was between 20 and 30. So you were okay if you wrote 23 or 29. They're only in the 1 times table and their own times table. I'm going to go for 23. It feels lucky. I'm going to go for it. Okay, question number 5. Find the number that is exactly halfway between 7 and 15. And guys, there is absolutely nothing wrong with writing out 7, 8, 9, 10, 11, 12, 13, 14, 15 and saying, right, what's in the middle? It's going to be 11. Nothing wrong with that. However, there is a better way, and that's going to be to average them. So if you want to average them, if you want to go bang in the middle, you can just take the average. And to do the mean, we would add 7 and 15 together and divide by 2. 22 divided by 2 is 11. So if you ever want to go halfway between 2 numbers, you can always add them together and divide by 2. It's not 11.5, no, just 11 on that one. Okay, question number 6. And this is the sort of question that you'd lose marks on just for not reading it properly. I think everyone could probably have a really good go at this question, but not reading the question is going to be the problem on this one. So question number 6, Harry is planning a holiday for 4 people for 7 days. Here are the costs for the holiday for each person. So each person is spending £150 on travel. Each person is spending £50 per day on the hotel and spending money £250 each. Work out the total cost of the holiday for 4 people for 7 days. So the travel, the 7 days doesn't affect the travel. It's £150 to travel. But the hotel, we need to times that by 7 because we're staying at the hotel for 7 days or 7 nights. So we're going to do 150. We need to do 50 times 7. And that's 7 times 0 is 0 and 7 times 5 is 35. So we've got 350 for the hotel. And then spending money is 250. And we're adding that all together. And that's going to give us the total cost for each person. 0 add 0 is 0. 5 add 5 add 5 is 15. So 5 carry the 1. 1 add 3 add 2 add 1 is 750. Good. £750 per person. There we go. But that's just for one person, and they want the total cost of the holiday for 4 people. So we need to times that by 4. Foundation from 7 till 8, guys. Higher is from 8 till 9. 4 times 0 is 0. 4 times 5 is 20, so 0 carry the 2. And 4 times 7 is 28. Add the 2 is £3,000. Or you could double it and double it again, or you could do 750, add 750, add 750, add 750, and that's going to be 3,000. So well done if you said that. This is June 2019. Let me write it on my whiteboard because I feel like lots of people are going to ask, where can we see? Can we see there? No, it's not November. Try again. June 2019, and let me write it over here for YouTube. I've written November again. What is actually wrong with me? June 2019. There you go. Paper 1. Obviously, because we're doing non-calculated for tomorrow. Is that okay? 3,000 for that one. Well done if you got that. Question number 7. In Adam's garden, the flowers are only red or white or yellow or blue. The chart shows the number of red flowers, the number of white flowers, and the number of yellow flowers. The total number of flowers is 30. Work out the number of blue flowers. So we've got 8 that are red. We've got 10 that are white. And we've got 5 that are yellow. That adds up to 23. So in the graph, I've got 23 flowers. Yes, Coco Chanel, well done. Tears falling, absolutely perfect. Good. So if we've got 23 flowers that are red or white or yellow, we need to do 30, take away 23, and that gets us 7. So there are 7 blue flowers, and that gets us 2 marks. For part B, we need to write down the mode. So a lot of you will have your teachers having sung to you, hey diddle diddle, the median's the middle, you add and divide for the mean, the mode is the one that appears the most, and the range is a difference between. Less of a song, more of a rap, but hopefully you all enjoyed that. So the mode is the most common. The mode is the most common. Yes, well done. So the most common there was white because there were 10 of those. So the mode is not 10, the mode is white. The mode is the most common thing, not how many of them there are. Write down that it's foundation. Foundation 7 till 8, higher 8 till 9. Thing is, I write it down, but people still ask because they ask before they read it. Foundation 7 till 8, higher 8 till 9. Anyway, there we go. Question number 8. Write these fractions in order of size. Start with the smallest fraction. So on the non-calculator paper, they're going to want to get you to make all of the denominators the same. It's way easier to compare fractions if all of the denominators are the same. So we're going to make all of these out of what? What would be a good common denominator for all of these fractions? What could I make them all out of? What can I make them all out of? I need a number that's in the 3 times table, the 4 times table, the 4 times table, the 12 times table, and the 2 times table. Good. Well done, Emma. Well done, everyone in the comments. Amazing. Simon, yes. From Jazz, yes. BGM, yes. Heinrich, yes. Anya, yes. Loads of you. Yeah, perfect. We're going to make them all out of 12. And that's because 12 is the first number that's in the 3 times table, the 2 times table, the 4 times table, and the 12 times table. What have I done to the bottom to make it out of 12? I've times it by 4, so I also need to times the top by 4. And that's going to be 4. With the second fraction, what have I done to make it out of 12? I've times the bottom by 3, so I also need to times the top by 3, and that's 9. With the third one, I've times the bottom by 3, so I also need to times the top by 3, and that's 3. With the next one, I've times the bottom by 1 or left it the same, so that's going to be 7 still on the top. And with the last one, we've times the denominator by 6, so we're also going to times the numerator by 6. There we go. And now we can compare them. And for ease, for the examiner, I'm going to put the fractions back in their original format when I write them on the answer line. So the smallest is going to be 3 out of 12, and that is a quarter. So we're going to write that one first, and I'm going to write it in its original format. The next smallest is 4 out of 12, and that's a third, so write that next. If you're going to cross it out, that's quite helpful, I think, to see that you've got them all. But remember that the examiner still needs to read your working. So make sure you don't, cross it out so much that we can't read it. 6 over 12, and that's going to be the next smallest, so that is a half. 7 over 12. I can't believe there's actually over 2,000 of you watching right now, and it's actually blowing my mind. I feel a bit emotional about it, to be honest. No pressure. Thank you all so much for being here. And then 3/4, that's my last. Well done, everybody. 2 marks for that. Question number 9. Ruth left her home at 9 a.m. and walked to the library. She got to the library at 10:30. Ruth walked at a speed of 4 miles per hour. Work out the distance that Ruth walked. Okay, so remember that when we are doing speed, we're probably going to need that triangle: speed, distance, time. Now, we would like to know the distance Ruth walked. And we cover up the D and do the sum that's left behind. That's speed multiplied by time. So her speed is 4 miles per hour. And the time, well, we need the time in hours because she started at 9 and she got there at 10:30. That is an hour and a half, so 1.5. She was going 4 miles an hour for an hour and a half. So in the first hour, she would have been able to go 4 miles. And in the half an hour, she would have gone an extra 2. 1.5 times by 4 is 6. So she went 6 miles. That is a long old walk to the library, isn't it? Ruth got to the library at 10:30. She stayed at the library for 50 minutes and then she walked home. And she took an hour and a quarter to walk home. At what time did Ruth get home? So with these time calculations, I like to do it like a little timeline. So I think, right, she left the library at 10:30. We've got to go 50 minutes. Now it's going to take you half an hour to get to 11 o'clock. Always go to the next o'clock. That's easier. And then you've got 20 more minutes to get to 11:20. So she's stayed at the library for 50 minutes. So it's 11:20 when she's left the library. Blimey, she's spent so long walking to and from the library. She really wanted those books, hey? So Ruth took an hour and a quarter to get home. So let's go on an hour from there. Add 1 hour would be 12:20. And then we just need to add a quarter of an hour, which is the same as 15 minutes. So that's going to be 12:35. Now, if I write 12:35, I'm not going to get full marks. Why? Oh, I might turn my spotlight off. It's right in the way. Oh, is that better? Worse? I don't know. 12:35. Yeah, exactly. Well done, everybody. We need to say PM. I know it doesn't really make much sense that she would get home at 12:35 in the morning, but it's always good to know. Right, next one. Question number 10. Oh, my absolute favourite page. My absolute favourite page. T add T add T equals 12. Now I'm going to go right ahead and write that as 3T equals 12. When you are solving equations, what you do to one side, you're going to do to the other. So if you know that 3 lots of T equals 12, that's multiplication. We're going to do the opposite to get rid of it, and we're going to divide both sides by 3. So dividing this side by 3, dividing this side by 3, T equals 4. Very good. No, you wouldn't get the marks if you didn't put the units on the last one. No. T equals 4. Well done. You can't say it's 3 or 4. It is just 4. That is the only answer. I liked it better with the lights on. Exactly. 12 divided by 3. That's exactly what we've done. So the answer is 4. T equals 4. Well done if you got that. For part B, I would always put the answer in the answer box. I examine GCSEs, and when we examine, the first place we're going to look is here, and then we're going to check here. So if the answer's here, that's absolutely fine, but also you don't want the examiner to miss it, because we're only human at the end of the day. So when we solve equations, what we do to one side, we're going to do to the other. We would like to get x on its own, and at the minute, we've got this -2, so we're taking 2 away from x. I want to get rid of that, so I'm going to add 2 to this side, also add 2 to this side, so now x equals 8. And it makes sense, 8 take away 2 is 6, so we found a number that works in that equation. Same with this one. What you do to one side, you're going to do to the other. The first thing we're going to do is get rid of the +2. And we're going to do that by taking 2 away from both sides. So 6w equals 18. Very good. Loads of you in the comments. Coco, Savage, Hira, Spaghetti. Reading people's names makes me nervous. I'm like, what am I going to say out loud? And then we're going to divide that by 6. We don't want 6 lots of w. We just want w. And that equals 3. So first we took away 2 because that's the opposite of adding 2 and it gets rid of it. And then we divided by 6 because that's the opposite of timesing by 6. This is Edexcel June 2019, but it's going to be helpful no matter what exam board you're doing. That was a very nice page, I think, of algebra. So 4 marks available there for that one. Question number 11. Right. So every single one of you should either be thinking, oh, I do column method for this, or oh, I do lattice method for this. But you need to have a method. And if you're a parent watching, please chuck one of these at your child and check that they know how to do this without a calculator and check it on the calculator. It's the kindest thing you can do. Because if they ask this tomorrow, it will be 2 or 3 marks just for doing this. And they need a method. So there are 2 ways. I'm going to do it both ways. I'm going to start by doing 74 times 58 in the column method like this. So to do this, we're going to do 8 times 4, which is 32. So 2 carry the 3. 8 times 7 is 56. Add the 3 is 59. And then we're going to go underneath and we're moving over to the 5, but it's actually 50. So 5 times 4 is 20. That's why we put the 0 in. 5 times 4 is 20. So 0 carry the 2. 5 times 7 is 35. Add the 2 is 37. And then adding it up. 2 add 0 is 2. 9 add 0 is 9. 5 add 7 is 12. So 2 carry the 1. And 3 add 1 is 4. So 4,292. If you ever make mistakes that way or you just don't like that way, then my solution for you would be the lattice method. So for the lattice method, we're going to draw 2 boxes going across because this is a 2-digit number and 2 boxes going down. 74 times 58, and obviously you can make it longer if there's more digits. Every single box, you're going to split it diagonally to the left, like Beyonce. Make it a little bit longer at the bottom. 4 times 5 is 20. 4 times 8 is 32. 7 times 5 is 35. And 7 times 8 is 56. And then all you need to do is add down each diagonal section. So in the first diagonal section, I've just got 2. In the next diagonal section, 0 add 3 add 6, that's 9. In the next diagonal section, 5 add 5 add 2, that's 12. So we're going to put 2 and carry the 1. And then 3 add the 1 is 4. So exactly the same answer, 4,292. Now, if I were you and I had some time at the end of the exam, I might do it both ways. Just because then you definitely know you're going to get it right. If you've never been taught this method, don't worry. Both of those are on the mark scheme for GCSE. So as an examiner, I'd be looking out for either of those methods, absolutely fine. Some of you might do the grid method where you do 70 and 4 and 50 and 8. It's not my favorite, but it's also on the mark scheme. So that's another option, but I find that one a little bit, goes wrong a little bit more often, shall we say. Okay, question number 12. AB and BC are perpendicular lines. So perpendicular means they are at right angles to each other. Parallel means they're going in exactly the same direction. Perpendicular means they are at right angles to each other. And we need to work out the value of x. Yeah, lots of you in the comments. Well done, Megan. Well done, this person. I don't know who you are. Well done, Callum. Well done, Paige. Well done, R. Well done from Jazz. This is June 2019, paper 1. There we go. So we know that this needs to add up to make 90. It's a right angle. Now I'm going to say, whenever in the paper you see a right angle, draw a right angle in, because sometimes it's worth a mark. Sometimes you'll just get a mark just for drawing in the right angle. So we're going to do 90, take away 50, because the 25 add the 25, that makes 50. So we'll take that away, and what's left is 40 degrees. So find the value of x, that is 40 degrees. Okay, and now we have some parallel lines. Now I want to look at this quite carefully because I feel like there's lots of things here that we could be asked about. So it says an angle of size 125 degrees is drawn. Write down the letter of one other angle of size 125 and give a reason for your answer. Now there are 2 choices here, but you have to give the reason to get the mark, I think. Oh no, 2 marks, okay. So we could say B. I think it was on the end. Oh, it wasn't. You're right. Oh, no, it's okay. You don't need the degree sign because it was on there. So it's asked me what X was and the degrees was there. So I'm okay with that. So they're saying, which other one is 125? Now you've got 2 choices. This angle here is 125 because opposite angles are equal. So you can say B is 125. Opposite angles are equal. Some of you will have been taught vertically opposite. That's absolutely fine. Either is fine for the mark. Opposite angles, vertically opposite is fine. Or you could say that D is 125. Now, the reason D is 125... Oh, I thought that was a highlighter. Is because corresponding angles are equal. So if you draw around this one, and you draw around this one, and you connect them, you get that F shape. So the other thing that you could have said is that D equals 125 degrees, corresponding angles are equal. So if you've watched me for a while, you'll know that I say corresponding and alternate. I think most teachers do. So if you've got that F shape, that's corresponding. So I just say corresponding because it helps me remember which one's which. And if you've got Z angles, you can't say Z angles. You've got to say alternate. So I always say corresponding and alternate because it helps me remember which one's which. And then if you've got that C shape, so if we looked at, for example, here, if we went round like this, what do I know about C and D? Can anyone tell me that rule? It's not relevant for this question, but can anyone tell me what's the connection between C and D? What's the connection between C and D? Co-interior, brilliant. Well done, Rain. Yeah, good. Supplementary works as well, so does allied. So any of those is fine. I would say co-interior, but that's absolutely fine. Co-interior angles, and they add up to make 180. Good. So the C shape, that adds up to make 180. F is corresponding and they're equal. Z is alternate and they're equal. So next question, I've got sidetracked as per usual. So either of these answers would be correct. You didn't need to write both, you just needed to write one of them. Explain why A add B add C is 235. So why is that bit 235? And the reason is angles around a point add up to 360 degrees. Now, the most common mistake I'm going to get on that is angles in a circle, okay? It's not a circle. It's angles around a point. Yeah, there we go. A couple of you saying circles. Not a circle. It's not a circle. There's no circles anywhere in that, okay? I know the lines of the angles look a bit like a circle, but there's no circle there. We say angles around a point. So make sure if you go to write angles in a circle, it's not angles in a circle, it's angles around a point. Brilliant. Question number 13. The length of a line is x centimetres. Write down an expression in terms of x for the length of the line in millimetres. Now, this is really tricky because you've just got x. Now, if I said to you the line is 20 centimetres, how would you get that into millimetres? If I said to you the line was 20 centimetres, how many millimetres would that be? It doesn't matter if it's Edexcel, it's going to be helpful whether you're doing AQA, AQA or OCR, don't worry about it, or any of the other ones. Good. We would times by 10, and it would be 200 millimetres. If I had 3 centimetres, that would be 30 millimetres. And if you didn't know that, I would highly recommend that you go to the shop in the morning, go to your biggest Tesco or whatever, and get yourself a ruler that's got centimetres on one side and millimetres on the other, because then you can basically just take it into the exam. So to go from centimetres to millimetres, we need to times by x. But they told you that it was x centimetres long. So if I had x centimetres, I need to still times it by 10. So it's going to be 10x as your answer. Some of you writing x times 10 or 10 times x. You're right, but we don't write times. We write 10x. No, if you need tracing paper, just ask the invigilators. I know they're scary, but they are there to help you. Work out a fifth of 70. Work out a fifth of 70. Eleanor, the app I'm using is PDF Viewer. A fifth of 70. So remember, a fraction of an amount, you are dividing by the bottom, and then whatever you get, you're timesing by the top. Divide by the bottom, times by the top. So 70 divided by 5, we're going to use a bus stop method for that. How many 5s go into 7? That fits in once, remainder 2. And how many 5s go into 20? That fits in 4 times, which makes 14. So now we've divided by the bottom. We can times by the top, but that's just 1. I don't think they'll let you take plain paper in with you, no. Okay, Fiona has to work out the exact value of 48 divided by a half. And she says 48 divided by a half is 24. And she says there are 2 halves in 1. So there'll be 24 halves in 48. Explain what is wrong with Fiona's reason. I think anything you write on in the exam has to go off with your exam. You can ask for extra paper and it will be sent off with your exam, probably. So she's wrong, isn't she? If 2 halves equals 1, then in 48, there's not going to be 24 halves. If this is times by 48, this side is also going to times by 48, and that would be 96 halves. She's gone the wrong way. So what she's actually done is times by a half. Now remember, if I gave you all a piece of paper, or let's say I had, probably not all of you because I'm going to run out of paper. If I gave 4 of you each a piece of paper and I said, can you please divide them into halves? I then have 8 pieces of paper. So 4 divided into halves equals 8. So we're going to divide by a half, which actually times by 2. So dividing by a half is the same as timesing by 2. It is 96 halves. So 48 divided into halves is 96. Perfect, well done. Okay, you all want 13 again. So for question 13, we know to go from centimetres into millimetres, we need to times by 10. They gave you X centimetres, and because you wanted that in millimetres, you just have to times it by 10, so 10x. Okay, question number 15. And I think this is quite likely to come up. You haven't got a calculator tomorrow, so a really common question. Good, Coco, well done. This is foundation from 7 till 8 and higher is from 8 till 9. So we're going to start by doing the square root of 64, and that is 8. The square root means something times something that equals 64. And we're looking for the same number times by itself, and that's going to be 8. 8 times 8 is 64. Well done. Yes, well done, everyone in the comments, well done. And lots of you giving me the answer to the second one as well. Well done, Sophie. Well done, Sarah. Wonderful. Yeah, so 5 cubed means 5 times 5 times 5. 5 times 5 is 25. And then we need to times that by 5, and that is going to be 125. So well done if you said 8 for part A and 125 for part B. Right. Oscar, I hope you're watching, and I hope you're going to do these two for me. Okay, expand 5 lots of 2m minus 3. So we're going to do what's on the outside multiplied by the first thing and what's on the outside multiplied by the second thing. Expanding just means multiply it out of the bracket. So everything in the bracket needs to be multiplied by 5. 5 lots of 2m is 10m, and 5 lots of minus 3 is minus 15. So well done if you said that. The temptation, some of you will put 2, but remember you're timesing. If you forget that, you can always put a little times sign on the arc. They were 1 mark each, these. They were 1 mark each. So you had to get both of those to get the mark. This is foundation from 7 till 8. Higher is from 8 till 9. And then factorize means put into brackets. Factorize means put into brackets. So the first thing we need to do here is see what do they have in common. And they both have 3 in common. So we're going to take a 3 and put it outside the bracket. And then we need to think 3 times something that makes 3n and 3 times something that makes 12. So what would we put inside the bracket? Lee, you're absolutely correct. You don't need the 1 though. It doesn't matter. You wouldn't get marked down for it. So we need to put an n here. 3 lots of n is 3n. And 3 lots of 4 is 12. So well done if you said 3n plus 4, or 3 lots of n add 4. Yes, perfect. If you put 1n, you're still going to get full marks on that one. Doesn't matter, but you don't need it, okay? Well done. Question number 17. Stuart throws a biased coin 10 times. So a biased coin is one that isn't fair. It's more likely to land that way than the other. Who's spreading negativity? I won't have it. I won't have it. Only positive vibes here tonight. Thank you so much. Stuart throws a biased coin 10 times. He gets 7 tails. Maxine throws the same coin 50 times. She gets 30 tails. Prasha is going to throw the coin once. Whose results will give the better estimate for the probability that she will get tails? Stuart's or Maxine's? You must give a reason for your answer. So this is such a common question. I've seen this come up on almost every paper now. The more times you do something, the more accurate are your results. I like that. Someone said Maxine because she chucks it more. I'll take it. Maxine, as she does more trials. So when we do something and we're doing a probability, it's called a trial. But the person that said Maxine because she chucks it more, you're still going to get the mark for that. As long as we know what you mean. The more times you do it, she throws it more. Perfect. Someone said they love me. Thank you, I think. Same paper for hire, June 2019, paper 1. So the more times you do something, the more accurate your results are. The results are more reliable. You do it more. Well done. Use Stuart and Maxine's results to work out an estimate for the probability that Prussia will get tails. So what's even better than using Maxine's results would be putting Stuart and Maxine's results together, because actually then they've thrown it 60 times, which is even more reliable. So 50 times, add 10 times. Between them, they threw it 60 times. Stuart got 7 tails and Maxine got 30. So the probability of landing on tails using both of their results is 37 out of 60. Oh my goodness, we're up to 2,200 of you. Thank you all so much for being here. And please go and watch my YouTube videos after this. Question number 18. Was there any questions on that one? Hi! This is foundation, 7 to 8 is foundation, 8 to 9 is higher. Thank you, Charlie, for the dinosaur. Okay, the diagram shows a rectangular garden path. It is 600 centimetres wide and 120 centimetres tall. Wasim is going to cover the path with paving stones. Each paving stone is a square of side 30. Each paving stone costs £2.50. Wasim has £220 to spend on paving stones. Show that he has enough money to buy all the paving stones he needs. So when I work this out, I would say, how many paving stones can we fit going across, and how many paving stones can we fit going down? So I just need to know how many paving stones fit in each direction. Now, if it's 120 wide, let's start over here. Each square is 30 by 30. How many 30s are going to fit in 120? How many can we have up this way? So if I do 120 divided by 30, that is 4. So we can fit 4 tiles going up like this. I've not drawn them very well because they should be square, but there we go. So we can fit 4 tiles going that way. So we're going to have 4 rows. And this way, we need to take the 600 and divide it by 30. Now, always with exams, if you haven't got a calculator and you've got a division, write it like a fraction, because what you can do is just simplify it. So 600 divided by 30 is 60 divided by 3. And 60 divided by 3 is 20. So I can fit 20 going across. I'm not going to draw them because we'll be here till Christmas, but you'll have to believe me. There's 20 that fit across. So I'm going to have 20 going one way and 4 going the other way. So altogether, that is going to be 80 tiles that I'm going to need to cover that. He's not thought about grout, but we'll let him off. Each paving stone costs £2.50. So we now need to do 80 times £2.50. And I'm going to use this as a perfect example to show off my lovely method again. So I'm going to do £2.50 times 80. 0 times, oh, hang on, I haven't split them diagonally. Wait a minute. Wait just 1 minute. 0 times 8 is 0, and 0 times 0 is 0. 5 times 8 is 40. 5 times 0 is 0. 2 times 8 is 16, and 2 times 0 is 0. And then we're just going to add down the diagonals. So I've got 0 here, 0 here, 0 here. 6 add 4 is 10, so 0 carry the 1, and then we've got 2. Now, there were 2 numbers in the question, so £2.50 times 80. In this question, how many numbers are after the decimal point? In this question, £2.50 times 80, how many numbers are after the decimal point? 2. So in your answer, we're still going to have 2 after the decimal point. So there we go. I mean, we wouldn't leave them there, but that tells you where to go with the decimal. So that is going to be £200. So we're now just going to say, yes, he has enough. £200 is less than 220. Always you need a little conclusion. See, I know it's like that gif where you look away and you look back and the maths person's written all over the board and you've got no idea what's going on. Sorry about that. Okay, where did I lose people? Where did I lose you? Yeah, absolutely. So someone said, could you just do £2.50 times 8 and then times it by 10? Yes, absolutely you can. So if you didn't like that method, let's do it another way. Let's do, so 25 times 8. 8 times 5 is 40. 8 times 2 is 16. Add the 4 is 200. And because you've made that one 10 times smaller and you've made that one 10 times bigger, then the answer is the same overall. There's lots of different ways you could have done that, but ultimately it cost him 200 quid. I'm so pleased you're finding it helpful. Right, here we go. 100%. It has to be there. It's definitely going to be there. It's definitely going to be there. Good. So when we are adding or subtracting fractions, you need to find a common denominator. Now I'm going to do both methods here because I know some of you like that butterfly picnic bench method. Don't get me started. And some of you like to make the denominators the same. So that's absolutely fine. Let's do that. So to make these denominators the same, we're going to make both of these fractions out of 15. What have I done to the first fraction to make it out of 15? I've times the denominator by 5, so I also need to times the numerator by 5, and that's going to be 10. With the second fraction, I've times the denominator by 3, so I also need to times the numerator by 3, and that is 3. And now we can do 10 take away 3, which is 7 out of 15. Now, some of you will know to do the butterfly method, or I always called it the timesing TP, to be honest, which is when you do, what colour shall we use for it? Let's do green. This times this times this, and this times this. So 5 times 2 is 10, 3 times 1 is 3, and we put the minus in the middle up there, and on the bottom, 5 times 3 is 15, and that is still 7 over 15. Someone called it an upside down picnic bench method the other day, and I can't unsee it. Either way, it doesn't matter. Do whichever way works for you. So both of these methods would be for adding or subtracting. If we get timesing, we're only using KFC for dividing. So dividing is when you're using keep, change, flip. And we haven't got that here. So keep, change, flip is for dividing. Timesing, just about the nicest thing they can ask you. Because timesing, you don't need to make the denominators the same. You can just do the top times the top and the bottom times the bottom. So 2 over 3 times 3 over 4 is 6 over 12. We've got to put it in its simplest form though. So 6 over 12 is going to be a half. If Pythagoras comes up tomorrow, it will be a whole number one though. So it'll probably be 3, 4, and 5. Or 6, 8, and 10. It will be ones that are whole number. They wouldn't expect you to do it with a decimal. Okay, fabulous. Question number 20. Here are two squares, A and B. The length of the side of square A is 50% of the length of the side of square B. So this is half this, which means that 4 of them would fit. Oh, that is... See, I always tell you guys to use a ruler, and then I went and let you down like that. Sorry in advance. There we go. So 4 of them would fit in that shape because this is half. So 2 of them would fit that way and 2 of them would fit that way. The length of the side of square A is 50%. Express the area of the shaded region of square A as a percentage of the whole area of that shape. What would that be? Express the area of the shaded region, so that, out of the whole area of B. So we know that this is one section out of, if we were to split them all, this is one section out of 8. So it's an eighth. That's good, but we need it as a percentage. Now, each of these, if I coloured in a quarter, we know that a quarter is 25%. So if that much is 25%, what is half of 25%? A quarter is 25%. So an eighth is half of that, 12.5%. Yeah, well done. Quite tricky, that one. I think if you got an eighth, that's great. It is 12.5%. Well done. Okay. Do that question again. So because this is half of this, we know that 2 of them would fit going this way and 2 of them would fit going that way because it's a square. So that means that each of these would fit in here 4 times. So I want to know, if I put this inside this one, what percentage of the whole shape is shaded? What percentage of the whole shape is shaded? So this bit is one section out of, if I split them all into the same size area, this is one section out of 8. So it's an eighth of the whole area. Or maybe let's do it another way. Let's have a little look at it a different way. If I said this had an area of 10, then this bit would be 10, 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 and this, and that bit would be 10. So the area would be 10 out of 80, which is an eighth. Now we want that as a percentage, and it's half of a quarter. An eighth is a half of a quarter. So a quarter is 25%. And we want to half that because we want half of a quarter. And so that would be 12.5%. Hopefully that makes some sense now. Okay. Question number 21. There are 40 students in a class. Each student walks to school or cycles to school or gets the bus to school. There are 22 girls in the class. 9 of the girls walk to school. 7 of the boys cycle to school. 6 of the students who get the bus are boys. Right. So this is either going to be a Venn diagram where you've got them walking or cycling or whatever, but no one is doing both. They're not walking and cycling. So it's not going to be a Venn diagram. This is going to be a two-way table. So when you do a two-way table, we want the mode of transport going one way. So we're going to do walk, cycle, and bus. And don't forget to put total on the end. And then we're going to do girls, boys, total. There we go. Two-way table, two-way table, two-way table. Exactly that. Yeah, perfect. Well done. So there's 40 students altogether. So we can go ahead and say that 40, the total, is 40. No, you do not have to draw the table, but I would really recommend that you do. This is foundation, but we're very much at that point now where it could be on the higher paper as well. The next question is the first question on the higher paper, so we're very much there now. Anyone could have this question on their paper. There are 22 girls in the class, so the total for the girls, this number at the end, is 22. 9 of the girls walk to school, so that goes there, and 7 of the boys cycle, so that goes there. 6 of the 10 students who get the bus are boys. So 6 out of 10, there are 10 students that get the bus, and 6 of them are boys. And all we now need to do is fill in the gaps. So I know that if there were 22 girls, there are going to be 18 boys, because that's 40 take away 22. I know that if 6 boys got the bus, 4 girls got the bus, because 4 add 6 makes 10. I also know that 9 add 4 is 13. So we need 9 more students cycling so that adds up to make 22. 9 add 7 is 16. And then 16 add 10 is 26. So I need 14 more here, which means this is 5. And let's just check. 6 add 7 add 5 does make 18. So we're just filling in all of the gaps. It then says, find the number of these students who walk to school, and that is going to be 14. That's the total number of students who walk to school. Now, a really common part B for that would be, I'm going to kick who out? Be nice in the chat or I will remove you. Woody, it's not too late. I might kick you out in the morning. Good. Question 22. There are only, I was going to say, a common part B is for them to say, I'm going to pick a student who gets the bus at random. What's the probability they're a girl? And in which case, if I'm only picking from students who get the bus, it would be out of 10, and it would be 4 out of 10. No, I'm not doing it in the morning. One of my year 11s is in the chat. I might kick him out of my actual physical classroom in the morning if he's not being nice on the chat now. Question 22. There are only blue cubes, red cubes, and yellow cubes in a box. The table shows the probability of taking at random a blue... Oh, wait. Stop. Megan. This is the first question on higher. So wait a minute, because I'm not going to do this till 8 o'clock. But the last question on this paper will just be foundation. This one. This one. Okay, I'm going back. I'm going to do this one first. Megan is a wonderful young lady who always organises me, and she always seems to know what papers I need to do. So I was going to ask Megan, because Megan tends to know. Yeah, exactly. Look, Austin knows as well. Sam knows. Look, my subscribers, they're here they know. Right, question number 29. Here is the graph of y equals x squared minus 2x minus 3. So this is a quadratic because of the x squared. Start paying Megan. I know, right? Well, TikTok would have to start paying me more first. Write down the coordinates of the turning point of the graph. So this is the turning point here. It is quite literally the point where it turns. So that coordinate, that point there, is 1 minus 4. Along the corridor and then up or down the stairs. And then use the graph to find the roots of the equation. So the roots of the equation are the 2 places where it crosses the x-axis. So the roots or the solutions are these 2 places here. It's when your graph crosses the x-axis. The turning point is the point where it turns. So this point here is your turning point, 1 minus 4. And the roots of the solutions here are just the 2 places where it equals 0. And that's going to be x equals minus 1 or 3. And that would be the final 3 marks of the foundation paper. So if they ask you for the roots, or if they ask you for when it equals 0, it's these 2 places here. You're looking for the 2 places where it equals 0. If you are Izzy, I forgot to email you back. Sorry. Exposed myself there, haven't I? These are the 2 places where it equals 0. Those are the roots or the solutions. And this is the turning point, the point where it turns. So if they ask you for the turning point, oh, about to hit 100,000 likes on that. There we go. Yeah, you need to put both to get both marks there. Good, right. Wonderful. Okay, so I'm going to give you all a 2-minute break now, a 3-minute break. My tea's gone cold, which is never good. And then I'm going to start again on the higher paper, because the higher paper starts on question 22. So all of the rest of these questions are now on the higher paper. So at 8 o'clock, we will carry on doing the foundation paper. And that's the last one that's going to be on that. So let me just get it up. That's not it. I've got too many papers open. Look, this is like my brain, this. That one? Yeah, there we go. So the first question on higher is question 22. And then you will go up to here. So question 7 was the end of foundation. So if you're foundation, that's where you're going to watch up until. Okay, and then we'll start the higher paper. I'm going to give you all a few minutes. Go and get some water. Go and get a drink. I'm going to make another cup of tea. So we'll start at 8. So if you're foundation, carry on watching. And anyone else, come back at 8 o'clock. Oh, I'm just going to stay on. I'm not going to go anywhere. But go and get yourself a drink. Give yourselves a few minutes. We've got 5 minutes till 8 o'clock. So go and get a drink. Go and get a snack or whatever. I'm going to go and get a cup of tea because I don't want to lose my voice. Thank you. So someone gave me honey today, and I don't know who it was. Someone gave me some honey, and I just want to say, whoever you were, thank you so much. It was the most thoughtful thing for my voice. How nice was that? Thank you, everybody. And I'm going to, be back at 8 o'clock for the higher, okay? And for the rest of foundation. Well done, everybody. Thank you so much. This is going to be filmed. It will be up on YouTube at the end. It will be up on YouTube at the end. And my YouTube is Hannah Kettle Maths, the same as on here. Okay, go and get yourself a tea and come back. I'm checking people in the chat. I do want a cup of tea, but also I'm reading through. Thing is, right, there's someone in my class putting silly things on the chat, forgetting that they're in my class, so I have their mum's contact details. Silly billies. Right, I'm actually going to get tea now. I'll be back. go. Let's go, let's go, let's go. Let's go. So we're still carrying on with foundation. So if you're doing foundation, yeah, if you're in year 9, absolutely join along. All good. Year 10 and year 11, all good. Okay, great. It does not matter if you do foundation or higher. A grade, like the grades are the same. If you get a grade 4 or a grade 5 on foundation or higher, no one will ever know the difference because it just doesn't matter. They don't know. No one will know which one you sat. It doesn't even matter anyway. Okay, it's 8 p.m. Let's go. So we're still on the end of foundation. We're also on the start of higher. Question number 1. There are only blue cubes, red cubes, and yellow cubes in a box. The table shows the probability of taking at random a blue cube from the box. So the probability of blue is 0.2 or 20%. The number of red cubes in the box is the same as the number of yellow cubes in the box. Complete the table. So red and yellow are the same. We know it needs to add up to make 1. So I'm going to do 1 take away 0.2. And that leaves me with 0.8, which I'm then going to split between those. So that will be 0.4 and 0.4. Then it says there are 12 blue cubes in the box. Work out the total number of cubes in the box. So 0.2 equals 12 cubes. And we know that 0.2 is the same as saying 20%. So 20% of the cubes in the box are blue, and that represents 12 cubes. How could I find out how many cubes 100% is? That's one way of doing it. Yeah, we can times by 5 and say that's 60. The other thing to do would be to say, well, if this is 12, then 0.4 must represent double the number of counters or cubes, whatever it is. So that would be 24, and that would also be 24. And then you could just add those up. But however you do it, it's going to be 60. Great, question number 1. So that's 4 marks already. I should get the grade boundaries up for this paper to see how many we need. Okay, Dion needs 50 grams of sugar to make 15 biscuits. She also needs 3 times as much flour as sugar and 2 times as much butter as sugar. Dion is going to make 60 biscuits. Work out the amount of flour she needs. So to get from 15 biscuits to 60 biscuits, think about a clock. If you've got 15 minutes to 60 minutes, that's a quarter of an hour. It's 4 times bigger. So if she needs 50 grams of sugar to make 15 biscuits, then she's going to need 200 grams of sugar to make 60 biscuits. But she needs 3 times as much flour as sugar and 2 times as much butter. So 3 times as much flour is going to be 600 grams of flour because we're timesing by 3. And she needs 2 times as much butter as sugar. So that's going to be 400 grams of butter. This is higher and also foundation. This is the crossover section, foundation and higher. Therefore, work out the amount of flour she needs. Well, that's fine. That's 600 grams. And then it says she has to buy all the butter she needs to make 60 biscuits. She buys the butter in 250 gram packs. How many packs of butter does Dion need to buy? So 250 grams in a pack. 1 pack is not going to be enough. She needs 400. We wrote that above. Add another 250 is 500 grams. So we are going to need 2 packs. Yeah, this is the start of the higher paper from 2019. Don't worry, it'll get harder. It'll always get harder. Is light off better? Yeah, we'll go with that. Okay, question number 3. I'm very much expecting it. So this is going to be product of prime factors. I'm going to do it that way. You can, of course, just try and think of the biggest number that goes into 72 and 90. But I think this is a good opportunity for me to show you the prime factorization method. Light on. God, blimey. There we go. So I'm going to do it the prime factorization way, just so that we've all practiced it. So 72 is 8 times 9, which is 3 times 3, which is 4 times 2, which is 2 times 2. So 72 is 2 times 2 times 2 times 3 times 3. If they asked you 72 as the product of its prime factors, then that would be our answer. For 90, it would be 9 times 10, which is 3 times 3 and 2 times 5. So 90 is 2 times 3 times 3 times 5. Now, I know you can write 3 squared and things like that, and you can slow. Sorry, I'm going too quick. Too quick. I'm going to do it again. 72, you just need two numbers that multiply together to make 72. So 72 is, let's do 36 times 2, because it doesn't matter. And if you get to a prime number, you're going to circle it. 36 is 2 times 18. And 18 is 3 times 6. And 6 is 2 times 3. So whatever way you do it, you're going to get the same numbers that are circled, prime numbers, and then you're going to times them together. So 72 is 2 times 2 times 2 times 3 times 3. And then we're going to do the same for 90. 90 is 9 times 10. 10 is 2 times 5. So if you don't get to a prime number, you need to keep going until you've got all prime numbers. And then 9 is 3 times 3. So 90 is 2 times 3 times 3 times 5. Now, if you want the highest common factor, you're going to put them in a Venn diagram, and it will be the numbers in the middle multiplying together. So what have we got in both? I'm looking at this, and I'm looking at this. What have they got in common? So they've both got 2. They've both got 3. And they've both got another 3. This one's got a 2 and a 2 left over. And this one's got a 5 left over. If you want your highest common factor, it's all the numbers in the middle multiplied together. So we're going to do 2 times 3 times 3, and that is 18. So that is my highest common factor. If you then wanted the lowest common multiple, you would take that answer of 18 and times it by any numbers that are left on the outside. So I would times it by 2, times it by 2, times it by 5, and that would be 360. If you were asked for the lowest common multiple. So that one's a 3. So they both had a 3. They both had another 3. They both had a 2. That was what they had on both. This is non-calculator ready for tomorrow's exam. Thank you, Tom. So the lowest common multiple, the first number that's in both of their times tables, would be 360. Question number 4. The diagram shows the plan, front elevation and side elevation of a solid shape drawn on a centimetre grid. We've got the plan, the front elevation and the side elevation. In the space below, draw a sketch of the solid shape. Give the dimensions of the solid on your shape. What shape is this then? What shape is this? What are we representing? So the plan is the view from above. So from above, it looks like a circle. From the front, it looks like a rectangle. And from the side, it looks like a rectangle. What shape is that? Yes, Gabriella. Yes, Jessica. Well done. Yes, indeed. It is a cylinder. Don't worry about your spelling, but it is a cylinder. Even if you spell it with an S, it honestly doesn't even matter. As long as you can, as long as we know what you mean, we're happy with that. So cylinder, great. And we're going to draw it and we're going to give the dimensions. So I know it's going to be a circle on the top, a circle on the bottom, and then just joining that up. It doesn't need to be ridiculously artistic. It just needs to be clear that you know what it is. And we've got to put the dimensions on it. Now I can tell, because the view from the front is 5 tall, that this would be 5 tall. So I'm going to put 5 centimetres on there. It told me it was on centimetre grid, so that's all good. And then from the side, from the front, sorry, from above, the plan is the view from above, and we can see that that is 4 centimetres wide. Perfect. And that's it. Question number 5. It says, shape A can be transformed to shape B by a reflection in the x-axis followed by a translation. Find the value of C and the value of D. So first we're going to do a reflection in the x-axis. The x-axis is this axis here. So we're going to reflect it in that green line and put it underneath. Bye, Jazz. Thank you for your help. So if we're 2 squares away on this side, then we're going to be 2 squares away on this side. And we're going to draw it here. So we've reflected it underneath. Then it says it's going to be translated, which just means moved. So to translate, we're going to move it along the corridor, up the steps, across in the top direction. Oh, I think I might just turn chats off in a minute because I'm finding it hard to moderate the chat with people being annoying. And also teach maths at the same time. Oh, blimey. Okay, so the top number's left and right, and the bottom number's up and down. So left and right, and up and down. So the top number's left and right, negative is left, positive is right, and the bottom number, positive is up and negative is down. So with this, I want to go from this shape to this one. So we're going 1, 2, 3, 4, 5, 6 left, and then 1 down. Now left is minus, so this is going to be the translated by the vector -6, and then we want to go down, so -1. So C is -6 and D is -1. Question number 6. A shop sells packs of black pens, packs of red pens, and packs of green pens. There are 2 pens in each pack of black pens. 5 pens in each pack of red pens, and 6 pens in each pack of green pens. On Monday, the numbers of packs of black pens sold to the number of packs of red pens sold to the number of packs of green pens sold is 7 to 3 to 4. A total of 212 pens were sold. Work out the number of green pens sold. So we know that the packs are in this ratio, but that's not the number of pens in the ratio, it's the packs are in this ratio. So we need to take that and multiply it by the number of pens in each pack. So the ratio of 7, that's for the packs, but there are 2 pens in each pack. So 2 times 7 gives me 14. Now the ratio that has red pens, the packs of red pens, is in the ratio 3, but every pack has 5 red pens in it. So I'm going to do 5 times 3, which is 15. And the number of packs of green pens is 4, but there are 6 pens in each pack of green pens. 6 times 4 is 24. Adding all of that together, we get 29, add 24, which is 53. And we know that a total of 212 pens were sold. 53 times 4 is 212. So if I times this ratio by 4, I'm going to get 212. So 14 times 4 is 56. 15 times 4 is 60, and 24 times 4 is going to be 48, 96. And they just want the number of green pens that are sold. And that's going to be this one, 96. So because the ratio is quite a tricky question, that. So because the ratio was talking about the packets, we have to times it by how many pens. So the packs were in the ratio 7 to 3 to 4, but to get the ratio of individual pens, we needed to multiply the pack number by how many pens were in each pack. So that ratio, 14 pens to 15 pens, so 14 black to 15 red to 24 green, only added up to 53. But we knew there were 212 pens. So this ratio needed to be multiplied so that it added up to make 212. So this only added up to 53. And I knew that 53 times 4 was going to get me 212. I did 14 add 15 add 24, but I added those together in my head. 14 add 15 add 24. So these three added together is 53. That's where I got the 29 from, sorry. Okay, question number 7. Here are two rectangles. We've got QR is 10, so I'm going to put 10 centimeters there. We've got BC is equal to PQ. So that length there is equal to that length there. The perimeter of ABCD is 26. So the perimeter of this one is 26. And the area of this rectangle is 45. Now we know that area is base times height. So I can't work out the perimeter of this rectangle yet because I don't have enough information over here. But with this one, I can work out the area because it's base times height, and I've got the height. So something times 10 is going to be 45. So if I do 45, so base times height equals 45, and we know that the height is 10. Something times 10 is 45. 45 divided by 10 is 4.5. So we now know that x is 4.5. And if this one is 4.5, this one is also 4.5. And now we can do the perimeter. So the perimeter is going to be the distance all around the outside added up. So that's going to be 4.5 add 4.5 add, let's call this one y. Y add y equals 26. So we know the distance all the way around the outside is 26. 4.5 add 4.5 is 9. So 9 add 2y is 26. Take 9 away from both sides, and 2y is 17, which means y is 8.5. Why 26? Because it said in the question that the perimeter equals 26. How many marks? That was 4 marks. And that was the last question on the foundation paper that we hadn't done. So if you're a foundation, well done. That's the end of it. If you didn't watch yesterday's session, feel free to go and watch that on YouTube. And if you're higher, I will carry on until 9 o'clock. So we'll keep going for another 40 minutes. Well done. You've all done so well, and you will all be great tomorrow. Don't worry. How did I get 4.5? So because they told me the area of this rectangle was 45, I knew it was 10 times something that made 45. So I did 45 divided by 10 to find out that that was 4.5. And they told me in the question that these two sides were the same. You're so welcome, everybody. I hope it's been helpful, and I hope you feel more confident going into your exams tomorrow. You're so welcome. If you look on my TikTok channel, you'll see all of my upcoming one. Absolutely, you can stick around for higher. Nothing to stop you. Okay, question number 8. Work out an estimate for the value of root 63.5 times 101.7. So I normally always say, when you're estimating, round to one significant figure. But the problem with this is that I actually want to square root them. So it doesn't make sense to round it to 60. Yeah, I'll try and do a YouTube version. I'll try and do a YouTube short of when I'll be live so that you can see them on YouTube as well. I'm going to round them to square numbers. Good. So I'm going to round it to be root 64 times 100. And with multiplication, we can actually split that up to be root 64 times root 100. That's how surds work, or square roots work. And so that's going to be 8 times 10, which is 80. So we're saying that answer is roughly 80. Oh, thank you, Izzy. No worries. Good luck. You'll be great. Okay, next one. Now, this is quite tricky. It says 2.3 to the power of 6 equals 148, correct to 3 significant figures. Find the value of 0.23 to the power of 6. So there's a couple of different ways you can do this. I know that 0.23 is 2.3 times 10 to the power of minus 1. If we were to write it in standard form, it would look like that. Now we know that if I do that to the power of 6, that's going to be 2.3 to the power of 6, which we know is 148, times 10 to the minus 1 to the power of minus 6, which is 10 to the power of minus 6. And that would be, now we'd need to divide by 10 6 times. So the decimal point currently is here. It would take us 3 jumps to get 0.158. And then we'd go 3 more, so 0.000148 is your answer. That's one way of doing it. Okay, let's do it another way. We could say that 2.3 divided by 10 to the power of 6. We happy with that? So that is 0.23. They've told me in the questions, I think some of you are missing this. They've told me in the question that 2.3 to the power of 6 is 148. So 2.3 divided by 10 is 0.23. And if I raise that to the power of 6, we know that 2.3 to the power of 6 is 148. And 10 to the power of 6 is 1,000,000. So whichever way you look at it, we've still got to divide it by 1,000,000, or divide it by 10 6 times. And that's going to be 0.000148. Foundation was 7 till 8, higher is 8 till 9. If you missed foundation, it's streaming live on YouTube, so you can go back and watch that. Okay, 5 to the power of minus 2. When you have a negative power, A negative power is going to do the reciprocal. Right, let's do some reciprocal practice. The reciprocal of 2 is a half. The reciprocal of 3 is a third. The reciprocal of 8 is 1 over 8. The reciprocal of 2 over 3 is 3 over 2. The reciprocal, you're just going to invert it. So that minus power makes 5 its reciprocal. So the first thing I'm going to write is that this is 1 over 5. Oh, pen would be helpful. 1 over 5 squared. 1 over 5 squared. And that's going to be 1 over 25. Someone said, really confused why there's a million here. And that's because I'm doing the top number to the power of 6 and also 10 to the power of 6. Everything needs to be raised to the power of 6. And 10 to the power of 6 means 10 times 10 times 10 times 10 times 10 times 10, and that is a million. EJ, I promise you I'm not waffling, and I am in fact correct. Question number 9. Work out 3.5 times 1 3/5. And again, multiplication is the nicest one we could get. And we're just going to make both fractions top heavy first. So big times bottom, add on the top. This is 7 over 2 times, and then 1 3/5 was 8 over 5. Is 8 over 5. Timesing fractions is the nicest question you can get. You don't need to make the denominators the same. You only need to make the denominators the same for adding and subtracting. So 7 times 8 is 56, and 2 times 5 is 10. Exactly that, well done. So that is 5 wholes and 6 over 10, which simplifies to be 5 wholes and 3/5. So 2.3 to the power of 6, we didn't have to do, everyone's really baffled on this question. We didn't have to do 2.3 to the power of 6 because it told us that was 148. We did 2.3 divided by 10 because they asked me to do 0.23 to the power of 6. I knew that 2.3 to the power of 6 was that, but 0.23 to the power of 6, we changed it so that we could still use the 2.3 divided by 6 to the power of 6. Question number 10. The graphs of equations 3y add 2x equals a half, and 2y minus 3x equals 113 minus 113 over 12 have been drawn on the grid below. Using the graphs, find estimates of the solutions of the simultaneous equations. This is the nicest question we've seen so far, and none of you are going to believe me. But if you don't know why, I will tell you why. This is the easiest question we've seen so far, I promise you. So with lines, x and y are just coordinates. So x is the x coordinate, y is the y coordinate. So x and y just need to make, so every single coordinate on this line, this coordinate, this coordinate, this coordinate, makes this one true. And every single coordinate, oh, the other one, sorry. And every single coordinate on the other line makes the other one true. So there is one place where both of these lines are true. There is one place where we are solving both of these at the same time. Every single coordinate on this line, so this coordinate, for example, is 1 minus 0.5. That, if you substituted the x in and you substituted the y in, would make the equation of that line true. And every single point on that line makes that one true. There is a point here where both of the lines would be true. Both of the coordinates would be true at that point. And that coordinate is 2.25 minus 1.3. You are just saying the coordinates of the point where the two lines cross. All you are doing with simultaneous equations on a graph is telling me the x and the y that is true of that point there. So if they ask you simultaneous equations of a graph, it's just where they cross. This line, let's have a think about this. This line is the equation 2y minus 3x equals that. But it's all irrelevant. It doesn't matter. This line is 3y add 2x equals a half. So every single coordinate on this line makes this equation work for x and y. And every single coordinate on this line makes this equation work for x and y. So at that point there, both of them are true. Okay, question number 11. A bus company recorded the ages and years of the people on coach A and the people on coach B. Here are the ages of 23 people on coach A, 41, 42, 44, 48, 52, and so on. Complete the table below to show information about the ages of the people on coach A. So we know that the least age was 41, that's the youngest person, and the greatest was 79. And luckily for us, they've put this in order. The median is just the middle. So there are 23 people here. Now, the quickest way to do it is to add 1 and divide by 2. So 24 divided by 2 is 12. So we are looking for the 12th person. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 59 is your median. You could cross off the top and the bottom, but 59 is going to be the median there. Now, the lower quartile is halfway between the middle and the bottom. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 people underneath the median. You always add 1. I have got 5 fingers. If I want the middle finger, it is not my 2.5th finger, it is my 3rd finger. 5 add 1 is 6, divided by 2 is 3. So if you ever want the position of the middle, you add 1 and divide by 2. So there are 11 people here. If we add 1 and divide by 2, it is 6. So 1, 2, 3, 4, 5, 6. Or you can just look. That would be our lower quartile. 53 is halfway between the middle number and the bottom. And then we also need to go halfway between the middle and the top, and that is our upper quartile. So that is 66. Here is some information about the ages of people in coach B. So this is coach A and this is coach B. And now we need to compare them by the looks of it. Richard says that the people on coach A are younger than the people on coach B. Is Richard correct? So we don't necessarily know that they're all younger, but we can compare the medians. So we would say on average, if you look at the median of coach A is 59 and the median of coach B is 70. So not all of the people are younger. So we don't know the individual ages of coach B, but the median for coach A is less than coach B. So on average, they are younger. Happy with that? Perfect. Richard says that the people on coach A vary more in age than the people on coach B. Is Richard correct? So if we're looking for variance, if we're looking by how much they vary, we need to look at the interquartile range or the range, and you'd be fine to do either. Now, the range is going to be the greatest age, take away the least age for each. So the range for coach A is 79 take away 41, which is 38. And the range for coach B is 85 take away 42, and that's 43. So we can see that the range B is more varied. So he says the people on coach A vary more. So no, coach B has a bigger range, so they vary more. Happy with that? So if you're looking at variance, if you're looking at consistency, you want to look at the range. Okay, question number 12. Here are 3 spheres, 3 balls. The volume of sphere Q is 50% more than P, and the volume of R is 50% more than Q. Find the volume of sphere P as a fraction of the volume of sphere R. Now, we don't have any values here. I can lower the brightness a bit, but then it blurs. Oh no, that's okay. The volume of sphere Q. So I'm just going to say that P is 100 centimeters cubed or meters cubed or whatever. Now, if Q is 50% more, we're going to add 50%. 50% of 100 is 50, so that one's going to be 150. And then it says sphere R is 50% more than Q. 50% of this is 75. So if I add on 75, then that's going to be 225. Yeah, they didn't give me any values. I don't know that it's 100, but it really doesn't matter because we're only working with proportion. If I increase any value by 50% and increase that value by 50%, I'm just going to get 3 values that are in the correct proportion. And they only want my answer as a fraction. So the fraction would simplify no matter what. So I now want the volume of sphere P, which is 100, as a fraction of the volume of sphere R, which is 225. And they didn't ask me to simplify it, but I'm going to. They're both in the 25 times table. So that's 4 over 9. It doesn't matter what values you pick. You would all get the same. It doesn't matter what values you pick. You would all get 4 over 9. So if we'd started, oh, that is way too dark. If we started with 50 and we times by, and we got an extra 50% and so on, exactly. You can times by 1.5 and then times that by 1.5 is going to be 2.25. Absolutely. It didn't say to simplify it, so you're all good. This is 2019 June. Okay, question number 13, and we've got algebraic proof. Given that n can be any integer such that n is greater than 1, prove that n squared minus n is never an odd number. So what I'm going to do is I'm going to factorise that. N squared minus n, I'm going to write it as n minus 1. And what that means is that is 2 consecutive numbers. So n and n minus 1 are 2 consecutive numbers. And what we know about consecutive numbers is that one of them will be odd and one of them will be even because they're just 2 numbers that are next to each other. So if n is even, then n minus 1 will be odd. And if n is odd, then n minus 1 is even. And so we can say odd times even is even. So it's never an odd number. Question number 14. Now, I feel like I need to do a late video on YouTube tonight on exact values, because I feel like all of you will be panicking on how to do your exact values. So your exact values are going to be, I personally just remember these two triangles. So I remember 1, 1, root 2, 45 and 45. That's actually not helpful for this question. And I remember 60, 30, 1, 2, root 3. And if you can remember those, then you can do all of them. There's different tricks with your hand and the table, and you can remember the table. That's absolutely fine. If you've got the table memorized, you're all good. I personally like to do this. So now if I want tan 60, you're stood here, and we know that tan is the opposite over the adjacent. So opposite over adjacent, which is root 3. Tan 60 is the opposite over the adjacent. Sine 60, if you're here, sine is the opposite over the hypotenuse. So tan 60, oh, it was tan 30. I didn't even read the question. Sorry. Tan 30, we're here. Tan 30 is the opposite over the adjacent, 1 over root 3. And we're timesing that by root 3 over 2. Now, if you've remembered the table, you might just do root 3 over 3. Yeah, you can use that method using, people have a hand, people do the exact trig value, exactly. Some of you will just remember the table. Some of you have got a hand trick. Yeah, exactly that. So it's this. So now we've got to do tan 30 times sine 60, which is this. 1 over root 3 times root 3 over 2. And the root 3's are going to cancel. So you've got root 3 over 2 root 3, which cancels. So it's just 1 over 2. And the answer was a half, which is why I always say to you guys, if it's an exact value question, just guess a half. Great. Question number 15. I've seen a few like this. The diagram shows a solid shape. The shape is a cone on top of a hemisphere. The height of the cone is 10. The base of the cone has a diameter of 6. The hemisphere has a diameter of 6. The total volume of the shape is k pi, where k is an integer. So rest assured, if it's on the non-calculator paper, then we're going to leave things in terms of pi, because we don't want to be times in by 3.14159 and so on. Okay, the diagram shows a solid shape. Great, let's do it. So we need to do the volume of the shape. Now, volume, they've given us both of the formulas, so all we're doing is putting values in. The radius is going to be 3, because the radius only goes to the middle of the circle. So we're doing the volume of the cone is 1/3 times pi times 3 squared times 10. I'm just using the formula. I've changed the radius to be 3, and I've changed the height to be 10. And then we need to add on the volume of the hemisphere. Now, a hemisphere is half a sphere. With your formula, if you just want half of this, the easiest thing to do is to change it. Instead of 4/3, just make it 2/3, because I only want half of that. You can do 4/3 pi r cubed divided by 2, but it's easier to just make it 2/3 pi r cubed instead of 4/3 pi r cubed. So we're going to do 2/3 times pi times 3 cubed. Okay, put that together. 1/3 times pi times, this is 9 times 10. Add 2/3 times pi times, and 3 cubed, this is the hemisphere, by the way. That's the hemisphere, is 27. Emery, it does actually, yeah, halves it all. Doesn't matter if you forgot to put pi because they're saying it's something pi, so you could just do it without the pi if you really wanted to. Now, this is 90, and a third of 90 is 30 pi. Now, 2/3 of 27, we're going to divide by the bottom times by the top, so that is 18 pi. So the answer is 48 pi. And so K, the number they're looking for, they said what number goes with the pi? It would be 48. Yeah, do you know what? You're absolutely right. So if lots of you not liking the fact that I've done that, and that's absolutely fine. So if I hadn't have done that, let's just go back to here. If I'd just done it as 4/3, just done the way they have, and then divided that by 2 afterwards, because I only want a hemisphere here. So it would have been 4/3 times pi times 27, all divided by 2. So you would have divided by the bottom, which would have been 9, times by the top, which would have been 36, and then halved it, and you still would have got 18 pi, and you still would have got 48. No, so in this, we would normally write pi with the answer, but if you look at the question, they said the volume is k pi, and they said, what is k? I think they probably would have allowed you all 4 marks if you put pi, but just be careful to read the question carefully. Question number 16. There are 3 dials on a combination lock. Each dial can be set to 1, 2, 3, 4, or 5. The 3-digit number 553 is one way the dials can be set, as shown in the diagram. Work out the number of different 3-digit numbers that can be set for the combination lock. So this is just the product rule for combinations is the topic. We've got 5 different possibilities for this value. We've got 5 different possibilities for this value and 5 different possibilities for this value. 5 times 5 times 5 is 125. I might film a video for exact values after this and put it on YouTube if that would be helpful. How many of the possible 3-digit numbers have 3 different digits? So now we're doing the same thing. I've got 5 different numbers that I can put in the first position. But whatever number I put here, I now can't use it in the next one. So now I've only got 4 that can go here. And then we've used up 2 different numbers. So then there's only 3 left that could possibly go there. 5 times 4 times 3 is 60. So those would be your answer. Exactly. Speedy got it. Well done. Okay, great. Question number 17. Now I'm seeing these more and more, and this is a very difficult one. So it says that x squared to 3x add 5 is in the ratio 1 to 2. Find the possible values of x. Now, I think the easiest way to explain this is if this had a value of 5, this one would have a value of 10 because they're in the ratio 1 to 2, right? So if this one had a value of 20, then this one has a value of 40. I would like to write an equation making them equal. And I know that if I double this one, then they'll be the same because that ratio is telling me that they are in the ratio 1 to 2. So in order to make them equal, I would need to say I need to double this side and then they would have equal value. So therefore 2x squared equals 3x add 5. So for them to be equal, I would have to double this side because they're in the ratio 1 to 2. I would need to double that left-hand side in order to make them equal. Now, to solve that equation, it's a quadratic. I want it to equal 0. So I'm going to take 3x away from both sides and also take 5 away from both sides. So 2x squared minus 3x minus 5 equals 0. And then we're going to factorize it. So I'm going to put 2x and x. I know it needs to be 1 and 5 because it's still going to multiply to make 5. If I put 5 here and 1 here, I would get 10x and 1x, and that's never going to be able to make 3. So let's put them the other way around. Let's put the 1 here and the 5 here, and that gives me 2x and 5x. So I'm going to put minus 5, add the 2, and that is now factorized. To solve it, we just need to say what would make that bracket equal 0 and what would make that bracket equal 0. So 2x minus 5 would need to equal 0. 2x would equal 5. So x would equal 5 over 2 or 2.5. And to make this bracket equal 0, x would just need to equal minus 1. So my answer is x equals 2.5 or minus 1. So I personally just trial and error it. This is higher. No worries, I hope you found it helpful. Yeah, exactly. So with ratio, if you know that x squared to 3x add 5 is in the ratio 1 to 2, you can just times that by that and that by that, and that will make an equation. So 2x squared is 3x add 5. So you're just multiplying the opposite side, and that makes an equation. Exactly that. Well done. Okay, now this one, I'm not going to do it because I've done it on the pack that I've put up on my YouTube. So on YouTube, I put up a pack. It is here, the top 5 topics for the non-calculator paper. That's got a booklet in the description. And in that question is in it. So I'm not going to do that question because I feel like if you want to see that question, you can go and watch that video. So both of those are in that pack. Let's try the next one. So this is completing the square. So completing the square, we're going to half the 6. And that is x minus 3 all squared. So halving that 6 gives me x minus 3 all squared. We then take away this number squared and bring down the plus 1. So this is x minus 3 all squared minus 8. So A is 3 and B is 8, because in this, they put the minuses in. Can you see? It said, write it in the form x minus A squared minus B. So the A, because it's minus, the A is just 3. If that was a plus, we would say that A is minus 3. But because the minus was already in there, that was okay. That topic is called completing the square. For part II, it says, hence, write down the coordinates of the turning point. And once you've completed the square, the turning point is just whatever makes this bracket equal 0, which is just 3. And then whatever number is here, whether it's positive or negative, that is your y coordinate. So can you see the B is negative in the instructions as well? So that's why the B is 8. Okay, question number 20. We're doing quite well. I feel like we're almost there. So just very quickly, let me look up the grade boundaries for this year. So this was June 2019. So we need to divide each of these by 3. So for a 6 on this paper, you needed 36 out of 80 for a 6 on this paper. For a 4, not very much at all, 18, 17. So you're dividing these by 3. We're doing June 2019. So if you divide these by 3, that's how many marks you needed on this paper. It was, can you see that June 2019, it was quite high actually compared to the others, but actually quite comparable to recent years. Yeah, no, it will be published on YouTube, this live. Okay, H is inversely proportional to P. So H is inversely proportional to P. Can't solve equations with fish in them, so I change it to H equals K over P. P is directly proportional to root T. Can't solve equations with fish in them. P equals K root T. So with proportion, you're going to change it to be an equals and a K. You can just jump straight to the equals and the K. That's absolutely fine. There's 2 of these questions on that pack, that same pack I just showed you. Now we're going to put in the values that we know. So when H is 10 and T is 144, when P is 6. So let's put all those values in. When P is 6, T is 144, and when P is 6, H is 10. So I've filled in all the values that I know. Now K, the square root of 144 is 12. Dividing both sides by 12, we know that K on this equation equals a half. So this formula is P equals a half root T. Because we've worked out that K is a half, we put that back in. On this one, we can see that if we times by 6, K is 60. So H equals 60 divided by P. Now we've got 2 equations. They want H in terms of T. We've got H in terms of P. And we've got P in terms of T. So what I'm going to do is I'm going to take this and put it where this P is. So that would be H equals 60 over a half root T. But I don't want to leave a fraction within a fraction. So I'm going to use equivalent fractions and double the bottom and double the top. So that would be H equals 120 over root T. You can say 0.5, absolutely. So if you said 0.5, you would have had 0.5 here instead, and you still would have wanted to double it. You can't leave it with a fraction at the bottom, no. You needed to double it to get it sorted. If it was 0.5, so if you guys wrote 60 over 0.5 root T, you still need to double it because you can't leave a decimal in your fraction. Did someone just turn up? You are 2 hours late. You are actually 2 hours late. Okay, I'm going to call it there. It's been absolutely lovely. There's only a couple of questions left. Do you know only 5% of people get a grade 9? So if you're one of those people on track to get a grade 5 tomorrow, grade 9 tomorrow, good luck. Well done you. So this question is on that pack on my YouTube. On YouTube, you've also got the predicted papers from first class maths. The papers for those are in the description. I've done top 5 topics for the paper tomorrow, top 10 topics for the calculator paper, although probably don't want to watch that one tonight. You've got surds, which would be perfect for tomorrow. You've got negative and fractional indices that would be perfect for tomorrow. And I hope you found that helpful. You've also got somewhere, oh yeah, live, look, last night's one. So there's 2 hours and 14 from yesterday. So if you're watching higher now and you didn't watch the one from yesterday, you've also got yesterday's paper there to do as well. And the higher starts at 1 hour and 10 in. I hope you found that helpful. There was lots and lots and lots on my YouTube. Please go and give it a watch if you think it would be helpful. It has been an absolute pleasure teaching you all. I will be on again live on, what day are we on? I'll be live again on Sunday, but only for subscribers. And then I'll be on again, I think, on next Wednesday. I think. Yeah. So Sunday and Wednesday, I'll be live again. Make a note. I'm not streaming tomorrow. No, I'm in school in the morning with my year 11s. So I will not be streaming. But I do wish you all the absolute best of luck. Sunday chemistry, I think I might get my husband to do a stream. Yeah, my husband is an incredible science teacher. So he might do a little takeover on Sunday. Yeah, I'm a teacher. I'm a head of maths. I'm a GCSE examiner. I've been teaching for 11 years. I'm so pleased you found it helpful. Thank you, everybody. Good luck for tomorrow. You'll be incredible. Thank you all so much. Good luck. Good luck. I'm sending you all the positive energy I possibly can. You will be amazing. Good luck. See you soon. Right, let's end this one. And let's end this one.